Hello, and thank you for joining us for ArcelorMittal's webinar with Automotive Manufacturing Solutions. My name's Gareth Price. I'm Deputy Editor for Automotive Manufacturing Solutions magazine. And today I'm joined by Alan Knight and Jérôme Favero from ArcelorMittal. In this webinar, Alan and Jérôme look at how greener steel production and smart steel solutions are helping to reduce the carbon footprint of future mobility. Before we begin, I'd like to invite you all to send questions for Alan and Jérôme to pick up in the Q&A session following the presentation. Just type the questions into the box in the lower right-hand side of your screen. Also, if you experience any technical issues during this session, please let us know using the Q&A box and our team will try to fix it. We hope you'll find the webinar stimulating and informative, and with that, I'll now hand over to Alan and Jérôme for the presentation.
Thank you, and good morning, good afternoon, depending where you are. So my name's Alan Knight. I'll be starting off the presentation, and my role is to introduce some of the work we're doing on carbon and some of the work we're doing on a new initiative called Responsible Steel, and then Jérôme will talk about some of the product innovation which is happening within ArcelorMittal to help you deliver some of your sustainability solutions. So we'll be talking for about 40 minutes and then we'll have questions. So very quick bit of context. I was in Sydney, Australia a few days ago for a piece of work linked with some of the material I'm presenting on this webinar. This is a typical tourist shop and it just highlights just how much steel is used in modern day society, from the ship to the bridge and the buildings and all of that. So our role is actually to find ways of carrying on providing this vital raw material, but reducing some of the carbon and other environmental issues associated with it. I think what's very, very exciting is not only what we see today, but if you browse through the literature of what people are saying about a future low carbon circular economy will look like, steel very clearly has its place in a low carbon, zero carbon now circular economy. So again, it just emphasizes that there's nothing wrong with steel. Our challenge is enhancing its sustainability credentials whilst reducing some of the issues you currently associate with steel in its production. As the world's largest supplier of steel, with many customers and many stakeholders, we get asked many questions about our environmental and social performance, but they summarize into three very broad themes. The first one is, what is your overall approach to corporate responsibility and sustainable development? And in brackets, I've got that acronym SDGs. They stand for the Sustainable Development Goals, which are 17 goals set by the world leaders and the United Nations on what the world needs to do to transition to give a good quality of life for 9 billion people forecast for 2050. So that's really just how you handle this issue overall. The second one, which is very high profile and is going to remain high profile for a long time, is what are you doing to move towards the agreements of the world leaders to be, net zero carbon by 2050? What are you doing today? And what is your transition to those very long-term but ambitious targets? How are you going to take the CO2 out of your production? And the third one is, reassure me that everything in your supply chain is okay. And by that, I mean not only steel making, but also the mines supplying the raw materials. And this ranges from every environmental and social issue possible, from child labor to pollution, climate change, labor rights, conservation of big nature, such as the rainforest. And it's this sort of constant need to be more reassured that all those different issues have been checked off in our long and complex supply chains. So what I really want to do is focus on the carbon question first, and then I'm going to tackle the reassure us that everything's okay question. It's no surprise to anybody that over the last sort of 2 decades, most of the focus on decarbonisation of the economy has been on energy making, hence the very successful transition in some parts of the world from from fossil fuel energy to renewable or clean energy. The last 2 years, however, have seen a new focus, and that's on materials, and particularly what people now call the hard to abate sectors. And aluminium, cement, and steel comes up. And as this line says at the top, steel production accounts for 7% of global emissions. And that's because there's so much steel out there. There's roughly 10 tons of steel per person in a developed economy. It's everywhere from the cars. Remember that photograph I showed of Sydney? So there's an awful lot out there. And what we're seeing is a lot of think tanks and people are now talking about what can be done to reduce the carbon in steel making. And perhaps the most interesting of those reports is the last one on this slide, the HSBC one, which is where we have a bank talking about what technologies and what policies do we need to take CO2 out of steel. And these reports all have one thing in common. They reinforce the point I've already made. The world needs steel. A low carbon circular world needs steel. The pressure is on how do we change steel making to reduce that 7% to a much smaller number, or ideally nothing. So the first starting point is the use of scrap. And one advantage steel has over some of the other materials we've listed is that it's very easy to recycle. I mean, we have recycling rates which are higher than the plastics industry's long-term ambitions. And the purpose of this slide is sort of slightly tongue-in-cheek, but to sort of reinforce the fact that probably all the steel in all the Model T Fords around in the beginning of the 20th century are probably still being used somewhere in new steel products. You do not throw steel away. It goes round and round and round. And as many of you who have done the numbers will know, the conversion of scrap into steel has a lower carbon footprint than the making of primary steel. However, that doesn't mean that our transition to low carbon steel can just be reliant on recycled scrap. And that's because the demand for steel is still growing and growing and growing, and there isn't enough recycled steel out there. Even at 90% recycling rates, we still need a lot more primary steel production. And so the rest of our focus of this talk, when I'm talking about carbon, is how do we change the way we make primary steel in order to reduce that carbon footprint. But simply moving over to scrap isn't the solution to the decarbonisation of steel, because we already use all the scrap out there which is being made available. So the first thing we did this year, but behind this is years of work, is actually publish our view on carbon. And we were the first steel company to actually have a dedicated bespoke report of over 40 pages, which outlines our approach as a primary steel maker to decarbonisation. And if you go to our webpage, you can download this as a PDF. So it's out there for you to read. The first thing we said in that report was just recognise the fact that we know we've got to be aligned to the ambitions from the Paris Agreement. So what we said back in June was that we know that we have to reduce significantly the carbon footprint of steelmaking. In Europe, because the policy regime is starting to reflect this ambition, we've gone one stage further, or in June we went one stage further, which is to say we'll be carbon neutral by 2050. And only this week we set ourselves a new target, a shorter term target, that by 2030 we recognise we will reduce our carbon footprint by 30% of our European steel companies. And the reason why we could be that bold now is to be aligned to the new European Commission's Green Deal. We know from that better policies will emerge, which gives us more confidence to set ourselves this clearer interim target of 30%. And what we do in the rest of this report is outline the different technologies we think are available to achieve both 30% and carbon neutrality. And our commitment as a big steel company is to test all of those different technologies and see which ones work, and then work with policymakers to create the right policy environment and the right incentives to roll them out. So the first thing we need to do is look at the technology. Just how do we change the way we currently make steel to achieve those very bold short and now long-term carbon targets. So the first one is to carry on using fossil fuels. And just to remind you, the reason why we use coal to make steel isn't just for the energy, it's also for the chemistry and physics of making steel, because we need something to reduce the iron ore, i.e. take the oxygen out of it, to turn it into iron and then steel. So for us, we need a source of energy, but in that energy, we also need a source of chemicals to do the reduction. So we need that's why it's not as straightforward to replace coal in steel making. So the first sets of technologies we're testing is we carry on using fossil fuels, we carry on using coal, but we capture the carbon which we emit from that steel making process, either store it or convert that CO2 into other useful products such as ethanol. So carbon capture and utilization. The second technology we can experiment with is to find a replacement for coal, using less coal. And here we have the option of using other carbon sources such as waste wood, waste agricultural waste. And this we turn into charcoal and then we can replace coal. The advantage of that is because it's a biological waste, it's circular. So as we are turning biomass into steel, there's a forest or farm somewhere growing new carbon. And to do that, they're taking CO2 out of the sky. So it's a circular carbon model. And the third technology, which is the most advanced, or the most technically complex and new, is to actually almost start again. And instead of using a carbon-based reductant, we use hydrogen in our steel making process, either by direct electrolysis or other solutions as well. So 3 different sort of energy vectors, ways we know that you can make steel and reduce the carbon footprint. So this is explaining these technologies in a little bit more detail. So this is linked to the capture of waste CO2. So this is a technology we're building in Ghent. Basically, we take the CO2 and the methane and we ferment it, and from that we can make ethanol. And from ethanol, you can make plastic and you can make fuel. So we're giving another use for the CO2 we produce, and we're building that technology in our plant in Ghent. This is the other technology which can be linked to the same technical platform. So instead of using coal, we use waste wood and we use plastic. We turn that into charcoal, and that then can replace some of the coal we use. So we're using waste wood, and since wood is circular, because we grow wood, we create that circular carbon technology. And as you can imagine, it's not rocket science to imagine a world where we're using waste wood, turning that waste wood into steel, and waste plastic, turning that waste wood and plastic into steel, and then using the CO2 and the methane to make new ethanol, to make new plastic. So you can see how in the future, a steel company could also be in the waste business and also in the ethanol business. And we could actually have a world where we're using the carbon in a circular way, times and time, round and round and round, to make new steel. This is the straightforward model where we literally just capture the CO2, we liquefy it, and then we take it to some available geology and store it underground. This technology's being tested, it's available. Many of the oil companies are embracing it. Others are anxious because they would much rather we didn't produce the CO2 in the first place. But our commitment is to test all these different technologies to see how viable they are, and also see how acceptable they are to wider society. And finally, this is probably the more radical of the solutions, as I hinted earlier, where we use hydrogen as the reductant rather than coal in the first place. And we're testing some of these technologies in Hamburg, and some other steel companies are also embracing what people now call the hydrogen economy. So what you see are several different solutions. And because we're a big steel company, our commitment is that we are testing all these different solutions somewhere in Europe to see which ones work, which ones we prefer, and then see which public policies do we need to make these all, which ones to be the more acceptable of all of them. So it's a big investment program, but you can't make steel without carbon without first testing the technology, and that's where our first focus is. However, our carbon strategy has to be bigger than that. And our carbon strategy, as outlined in that carbon report, has really sort of boiled down to 5 key interventions. The first one I haven't really touched upon, which is just rolling out best available technology where we're ready to have it to hand. The second one is the technologies I've just listed, actually test new technologies and new ways of making steel, so we're ready to roll them out. The third one is really important, is even in Europe, which has very progressive carbon policies, we still think, and we still know, in fairness, that we need policies aligned to our industry, which create more incentives and protect us from overseas competition, and they're not in place at the moment. So there's a lot more work to be done with policymakers to incentivize us and to speed up the pace of change. And then the stakeholders, you, our customers, our investors, have to understand what we can do, what we can't do, and where you can help us. So we're doing a lot there on making sure that people understand the steel story and the decarbonisation of steel. And then just understand, finally, what these new pathways would look like. All of them have unintended consequences, or, you know, the hydrogen economy needs a whole new industry to make all the hydrogen we need to do it. If we go down the biomass route, we need a lot more biomass available. So we have to understand what is the larger ecosystem to make these different technologies work. Hang on. So I had a little slide blip here. There we go. So let me just go to that second question. So that's what we're doing on carbon. And to remind you, only this week we've now committed to 30% reduction. The second question I really want to deep dive on is what's under this Responsible Steel initiative, which is customers wanting a greater level of reassurance that everything from mine site to steel making is okay. So we've all seen a lot of coverage on problems in mine sites. And as you know, steel requires a lot of mined raw materials. We've got more and more of the car brands asking us to have more transparent, audited supply chains. And some of you will be aware of the Drive Sustainability Initiative, where several car brands, and they're listed at the bottom of this slide, have started working together to identify where the higher risks lie in their supply chain. So the words on the left-hand side are sort of the different raw materials used to make a car, and you see that iron and steel features very loudly, and it's listed as high risk, not because there are loads of known risks in the supply chain, it's just that so much of a car is steel. So we've been working very hard and doing a lot of thought on how do we provide these new layers of reassurance. And it boils down to sort of 5 quick questions which we need to provide a model to answer. One, actually agreeing amongst a wider stakeholder group what good steel making looks like, agreeing what good mining looks like, agreeing how we measure carbon. Is it just about steel making, or is it the whole supply chain from iron ore mining, shipping, what people call scope 3? How do we have a common number so that people can compare us against all these different, against our competitors and other claims? Just knowing exactly what reassurances you want, what level of issues you want covered, and how do you want that promise expressed, and having a clearer sense of what claims and promises steel users, you, our customers, want to make to your customers. So we've got to create a model which makes a significant contribution to those 5 different asks or points. So the model we followed was built for the forestry sector, the Forest Stewardship Council. Some of you might recognize this logo. It's on many packaging and consumer products and building products. And if a piece of wood or paper carries this label, it's a promise that the forest has been managed to good environmental and social standards. And what makes that standard robust is that it was agreed not just by the forestry sector, but a wider group of civil society. So environmental groups, social groups, customers, competitors and suppliers, all gathered in a room to agree this standard. And this is where we're proud to introduce an independent organisation to ArcelorMittal, but one we've been very involved in for several years now, called Responsible Steel. and it replicates this model. So it's multi-stakeholder. This was a meeting we hosted in London in June last year. Different members gather and we talk about all the different challenges and requirements of steelmaking and mining to start drafting a standard. And here is just a selection of some of the companies who are already in formal membership. So these are companies, if you're a commercial company, you're paying a membership fee. If you're an NGO, you're not paying a fee, but of course you're risking your brand by being associated with this. And on here you'll see BMW, you'll see Daimler, you'll see Voestalpine, so it's not just ArcelorMittal, BlueScope, Lend-Lease. I know we're talking to Automotive today, but we've now got the world's largest construction company in membership. We've got some of the leading carbon NGOs in membership, like Mighty Earth, We Mean Business, CDP. We've got Clean Air NGO, trade unions, raw material suppliers, and even a bank, HSBC, are involved. And this group, we now have 53 members, all sit down and discuss the standard, and they have a voting right to vote or vote against the standard. So it's a truly multi-stakeholder process, and any organisation on this call are welcome to join Responsible Steel at all. And we've got a nice pipeline of new members coming in. So it's a really, truly stakeholder group, and perhaps the only one in the steel sector. So after several years' work, we now have a standard for steelmaking. And you can download this from the web. It's in the public domain. It's about 70 pages. And it's not just about carbon, it's about all these different issues. So 12 principles, social issues, climate change, water, effluent, everything. So all ESG issues, agreed by consensus by that membership. And you can see that this is a proper, believe it or not, there is a standard on how you set standards. So it takes over 2 years, 5 versions with public consultation, and only in November did the membership and the board agree the first draft standard. There's still opportunities for the standard to change and improve because nothing's right, but there is now a standard by which steelmakers can work to. And the idea is you then get assured, certified by independent auditors that you meet that standard. And we've also in November just signed off the assurance process. And this is the details about how a certifier can certify against that standard. So there's now nothing, this standard and the assurance scheme is now on the market. Steel sites can get certified against this standard, which is why only a couple of weeks ago, ArcelorMittal Flat in Europe committed to not just 1 or 2 sites, but getting its entire portfolio of sites in Europe certified under this standard within the course of the next sort of 12 months. So we're really going for it. And so, you know, just watch this space. But we're the first steel company in the world to commit any site, let alone such a large portfolio of sites, to meeting this standard. So in the last few weeks, we've launched an aggressive carbon target and a target to get all our sites responsible steeled. But of course, don't forget that I also mentioned mining. And those numbers on the left-hand side are some of the principal raw materials for steel, and the percentage is the market share of the steel sector of that particular mineral. So obviously we buy 100% of iron ore, but 75% of chromium, 60% of nickel. So we're a major player in the mining sector. Luckily for us, Responsible Steel doesn't have to set a mining standard. There are at least 3 out there. IRMA, which is the closest to the multi-stakeholder model, Towards Sustainable Mining, which isn't truly multi-stakeholder, but very close, but very well established in Canada and other parts of the world, and Better Coal, written just for the coal sector. So Responsible Steel is working with these 3 standards to actually find a way of combining them. The complication is lots of different mine sites go into one steel plant. So we've got some work to do to work out how we're going to do this. And that's the program for this year. So how do you combine certified mine sites with a certified steel site to give you, our customers, a certified product? So the DNA of Responsible Steel is you can become a member tomorrow. You can be involved in the discussions and the decision-making process. We as steelmakers can get our site certified against the steelmaking standard. And sometime next year, we'll have a way of combining steel sites and certified mines to be able to offer you a certified product, which is how we're going to tackle those 5 questions. The members decide. Number 1 is answered by the steelmaking site, and the other 4 questions will be wrapped up in a standard for certified steel products. And that's the work we're doing next year. But don't forget, it's a community of people, which is why you are more than welcome to get involved and join that initiative and be part of it. Very quickly, the last question. These are those 17 Sustainable Development Goals. 17 is a lot. So we at ArcelorMittal have our 10 Sustainable Development Outcomes, and all the countries around the world report against those 10 outcomes. So we're looking at all issues, and the 2 initiatives I've described today is where we're really driving transformation. So very quickly, a quick summary. The good news for us as a steel maker is steel is needed for a low carbon circular economy. Our challenge is transitioning the way we make primary steel. We're not afraid of the Paris Agreement, and we're fully committed to it. Carbon neutral by 2050, 30% reduction in Europe by 2030. We can't do this alone. We can test the technology, but you will see us having lots of conversations on people on to get the policy right. We recognise that our issues are bigger than just carbon, which is why we now have an independent standard on all environmental and social issues, not just for steel making, but for mining. And that's why our commitment to responsible steel is very, very important. And we hope you support that too. But that's only half the story. The other half of the story, the next half of the story, is how we're innovating steel to help you find the sustainable solutions you need for your product and your customers. And with that, I'm going to hand over to Jérôme, who's going to describe some of those innovations.
Yes, thank you, Anna. Thank you, Anna, very much for this introduction. So now let's move to the second part of the presentation with a focus on the automotive solutions, and with a more especially focus made on battery electric vehicle solution. So many initiatives took place from policymakers, from OEMs, to push the battery electric vehicles with the idea, in fact, to reduce the CO2 emissions. But from what we can see today is that depending on the hypothesis we take, battery electric vehicles are not necessarily emitting less CO2 compared to ICE vehicles engine. Here you have the example of a life cycle assessment analysis on the right hand side of both battery electric vehicle and internal combustion engine vehicles, and you can see that in fact only during the production phase we emit already a lot more CO2 emission, and also during the rolling phase, the use phase, today we still have some emissions despite the official communication we can see today. It's in fact linked to the fact that somehow we have to produce the electricity. So basically, we still have some margin for improvement for battery electric vehicles, and we can reduce the CO2 equivalent emission during the production phase. And here we think that steel can play a huge role. We will see later that we will see in the coming slide how. And we can also work to reduce the CO2 equivalent emission during the use phase. So as mentioned here, the energy mix is of course a key factor, but the lightweighting has also his role to play. So if we look at the material distribution on the battery electric vehicles, and especially the emission of CO2 equivalent related to the production, we can see that steel and iron is ranked at the second position. So it means that it's the second hotspot. Of course, we have to keep in mind that steel and iron represent more or less 60 to 70% of the car weight, and that explains this high position, especially if we compare with aluminium and the only 4% of aluminium. Here we have to take into account that steel is by far more used. But here what we see is that again steel and iron are the second source of emission. So it means that here we have an interesting potential of saving thanks to the optimization we can do thanks to material choice, weight saving, and material utilization rate. I will comment now on the next slide. There's 3 points which would help the car manufacturers to reduce the CO2 emission, equivalent emission of their cars. So first of all, which material should be used in a body in white? Of course, it depends on the application, and it's very complicated today to bring a kind of overall picture, but we think that working on a kind of generic approach where we take into account of the mechanical properties of the materials and also the forming yield of the material. So it means that for stamping, for example, we have to trim the part, where for some plastic injection we can have a very high yield because here we have no scrap. So anyway, when we take into account of all these factors, we can see that mild steel perform already very well, and this performance can even be improved thanks to advanced high-strength steels and thanks to the higher mechanical properties. So basically, if we compare to the different materials with the sourcing in Europe, we can say that steel is very, very well positioned today to design, let's say, a body in white with a quite efficient CO2 emission, equivalent emission performance. So now, in order to have a business case based on an application, I've selected here the battery pack. So the battery pack is a key element of the battery electric vehicles, and within our S in Motion projects, so the generic projects for the car manufacturers to highlight the added value of our steel products, we designed a battery pack by taking into account all the different crash loads and requirements in order to fulfill the safety of both passengers and battery packs. So if you are interested in this topic, you can of course go to our Automotive website or consult also the previous webinar on this topic. But yeah, so this solution, as I mentioned, is already designed with a high efficiency by taking into account of our last materials innovation and very advanced high strength steels with very high mechanical properties, such as MS 1500, so magnetic grade with a UTS of 1500 megapascal, which is in percentage more than half in the weight of the total battery pack. So now, in order to have a fair comparison with the aluminum solution, we designed, of course, the aluminum version by taking into account of all the different load cases. And of course, the idea was here to have the similar behavior, to have, let's say, not in an interchangeable solution, and in order also to have the fairest possible comparison, we took into account also of the last innovation on the aluminum supplier side. We consider, for example, some 6 and 7000 series. So what we can see if we perform a complete life cycle assessment, so without the use phase, because of battery electric vehicle today, there are still some strong hypotheses. We can see that we can save up to 36% of CO2 equivalent emission for the production of this battery pack by taking into account also of recycling credits. So if we speak about lightweighting, of course, lightweighting means less material to use, means less material to produce, means less CO2 released. So here I would like to highlight the added value of our new 40 form steel grades, which is a new family of the advanced high strength steels, and these grades with mechanical properties up to 1200 megapascals brings a very an enhanced formability, which is best in class for cold stamping, and in fact it allows quite directly to switch from conventional DP 800 to these 40 form solutions. So depending on different applications, we saw that we could achieve also very interesting mass saving which would bring also a very good reduction in CO2 equivalent emissions. So here you can see an example of a C-segment, a roof cross member. We were able to achieve up to minus 27% of CO2 equivalent emission. So this is possible thanks to, of course, the very high mechanical properties, which helps to reduce the thickness, but also to enhance formability, which gives also more flexibility to designer to maybe manage on a better way the crash, and by the way, continue to further reduce the thickness of the part to keep the same crash properties. So new advanced high strength steel innovations such as 44 can bring very interesting savings thanks to higher mechanical properties and best-in-class formability for cold stamping. Now I propose to continue to speak about lightweighting and to change a bit the topic, because now we will speak about hot stamping. So hot stamping is also a technology which helps, in fact, to further improve the safety of the cars thanks to the PHS steel. So press hardening steel, in fact, bring today the most advanced solution to achieve weight saving in the automotive application, thanks to three main aspects. The first one is the very high mechanical properties which are achievable on parts. The second point is the very high flexibility and formability. So it means that here we can form very complex shapes, and also an outstanding geometrical precision. So it means that you are not only able to produce very complex shape, but we master also the conformity of parts. On the other hand, we can have a kind of drawback, let's say, regarding the CO2 emission, because compared to conventional stamping process, we have here to add a heating step to heat the blank prior to the stamping process, with the objective to reach a temperature of more than 900 Celsius and keep the blank in the furnace during approximately 5 to 6 minutes. But at the end, in fact, when we look at the performance of the part, so it means the lightweighting which is the part able to bring, in fact, we see that this completely offsets the CO2 equivalent emission linked to the heating phase in the furnace. So this is why today we are confident to say that in most applications, in many applications, PHS solutions bring further CO2 equivalent emission reduction. I propose you a business case to highlight that effect. So we worked here on a B segment, and more especially on a tunnel part. So of course we had the constraint linked to the geometry, but also linked to the different crash loads, and also to the stiffness of the cars and to some NVH aspect. But we kept, of course, all these requirements, and we checked up to which mechanical properties we could make the part by considering both technologies, cold and hot stamping. So based on our results, this part would have been feasible in 40 from the 980 steel. So it means a UTS of approximately 1000 megapascal cold stamping, and in usable 1500, so it means a UTS level of 1500 megapascal. So it means that for the same application, we could have 500 megapascal more in PHS steel. So it means that we could have, by the way, downgrade the thickness of the PHS part to keep the same mechanical performance. So at the end, when we perform the LCA assessment, of the solution, we went to the result that the usable 1500 part is bringing 7% reduction of CO2 equivalent emission compared to the best-in-class cost stamping solution. So here it was a business case to highlight that press hardening steels can even further allow the car manufacturers to reduce the CO2 equivalent emissions. So we spoke a lot about the steel solution and the weight saving in order to save, let's say, material consumption. But we should not also forget the use phase of the vehicle. So of course, the performance is strongly related here to the energy mix. But anyway, if we consider today a kind of average European energy mix, we see today that if we reduce the weight of 100 kgs of battery electric vehicles, we can save nevertheless 3 grams of CO2 per kilometer, which is also not neglectable if we compare to an ICE diesel engine today, which allows to save 4 grams of CO2 per kilometer. So here as hypothesis, we took into account a C segment. And of course, we have another point which has also been taken into account and on the graph on the right-hand side is the downsizing of the powertrain and also on the batteries, which are also allowed by this weight reduction. So today, this is why, thanks to lightweighting, we can even further reduce the CO2 equivalent emission of battery electric vehicles by bringing lightweighting. Okay, last but not least, we have, as I mentioned in the beginning, a last great opportunity to continue to reduce the material consumption. It's here basically the nesting. So ArcelorMittal is very often delivering coils to the car manufacturers and other tier 1, and the tier 1, the other car manufacturers are here cutting the blanks before stamping it. Of course, here it's like a big puzzle, and the aim of the game is in fact to reduce or to find how to cut the different parts by reducing as much as possible the scrap. Here we can find an opportunity to optimize the nesting in case of very large parts by cutting them in two. And here the IMTB division from ArcelorMittal is able, in fact, to provide laser-welded blank to the car manufacturer with this optimization already done. So we will see now an application on the A pillar to bring you some more insight to help you to understand how attractive can be this solution. So on the left-hand side, you can see what would be the nesting of the A pillar. So of course here we have also a strong limitation is the feasibility of the coil. So this is why for very large parts it makes sense to study this kind of process. So basically, and with the standard process, we have a scrap rate of 48%. But if we decide to cut the blank in two and to weld it afterwards, even if we take into account the welding step, we achieve here a CO2 equivalent saving of 26% compared to the monolithic solution. And of course, it is for the OEM transparent because it's the same material, same thickness, and technically the parts, even with the weld, will behave on the same way. We can also highlight a very interesting cost benefit because in this case, we can save more or less €1 per car. So as a conclusion from my part, I would like to recall the main message I had the occasion to bring. So the first one is that even for battery electric vehicles, we have to remember that lightweighting can help to reduce also CO2 equivalent emission during the production and also the in-use phase. The body in white is the second hotspot after the batteries today when it comes to emission. So this is why it is important to continue to work on body in white and continue to do research on advanced high-strength steels and integrate them in order to have a more efficient body in white. So based on life cycle assessment today, we are we are confident to say that steel is the most sustainable material for many body-in-white applications. So we mentioned also that advanced high-strength steels and other top steel products can provide interesting solutions to reduce the emission thanks to the higher mechanical properties and also thanks to the higher formability. We already saw that press hardening steels, despite let's say a further heating step prior to the stamping process, is in fact at the end very often even more interesting than top cold stamping solution, because the lightweighting, the further lightweighting offers completely offsets the CO2 emission linked to the furnace and the heating step. And last point, solutions such as laser-welded blanks can be a powerful way to optimize scrap and improve the sustainability of the vehicle without changing car properties or design. And ArcelorMittal teams are ready to adapt to the constraint of individual OEMs and Tier 1 suppliers to share a deep knowledge of ArcelorMittal innovation product for optimal solutions. Thank you very much.
Okay, thank you, Alan. Thank you, Jérôme. Yes, we'll start looking at some questions now. And the first one, you mentioned your commitments in Europe, but regarding commitments in other parts of the world, what would they be for say, North America, India?
For responsible steel, our ambition is that this will be rolled out across the world. We're starting in Europe. It's a new initiative, so let's test it in one place to get it right for us and allow responsible steel to get it right. But we are talking to Brazil. We're talking to some of our colleagues in North America, and so the rest of the world is very aware that responsible steel is an important part of our initiative. The answer for carbon is similar. It's no surprise that because Europe has some very progressive policies on carbon, that it's a natural place to start. It's easier to get funding. We've got policies which create the business case for doing it. But the technologies we're testing obviously will work anywhere in the world. But we need more policies. We need better policies in Europe. And the problem with the policies in Europe is we need to have means to protect us from steel imports from countries which aren't making these investments or have a price on carbon, which is why we're talking about a carbon border adjustment. And other parts of the world need to start learning from Europe and start introducing similar policies there. But the transition to low carbon steel making isn't just about technology, it is about policy. So it's harder to have a consistent approach around decarbonisation of steel making at a global company when global policies are so inconsistent.
So with that said, then how important is it for support from other stakeholders such as governments when meeting your goals? It's
essential, which is why we're devoting time to say this event, the carbon report, and a lot more besides. I speak at many investor events, as do many of my colleagues, and we have a whole government affairs department dedicated to talking to government officials, particularly in Europe, to actually understand the potential of low carbon steel making. It is technically possible to make steel without carbon, but we need incentives, we need finance, and we need more consistent and fairer policies on the global stage. So we really do need support from policymakers. Obviously, we want customers just to understand what we're doing and the challenges. Sometimes customers ask us, why don't you just use more scrap? And I think in my presentation, I explained we use all the scrap that's available. We still need to make primary steel. And by engaging with the responsible steel community, you can be part of those conversations too. We can't do this alone. We're experts in steel making. We can test the technology, but that alone won't be enough. So please feel free to talk to us and become part of the initiatives we are creating to help this debate move on.
Okay, thanks. One of our questioners asks about biofuel, which I think was mentioned in the presentation. But what are your thoughts on biofuel charcoal?
It's one of the technologies we're testing. So we're building equipment at our plant in Ghent, where we can displace some of the coal we use and use waste wood instead. We don't think we need to use fresh trees. I think that would be too controversial, but we can certainly use the byproducts, the offcuts and the branches, which is what some of the power stations do. And we're certainly very interested in using waste wood, waste agricultural waste. And of course, there's another aspect where if the question's about biofuels, which is through the LanzaTech technology we're testing here, also in Ghent, we will be making biofuel. The ethanol we make from fermenting our waste methane and CO2 goes through a fermentation process. So technically, it will enter the market as a biofuel. So not only can we use biofuels to make steel, we will actually make biofuels in the steel making process in the future.
So a bit more of a more specific question here regarding 40form 1180. Is it suitable for axial crush applications?
Yeah, of course. So here we can have different applications from the front race up to the rear race, roof arch. So of course it depends on the crash load and on the position of the part on the car, but we have many applications in the body in white, and case by case we should have a look. But of course it's basically a steel with very high mechanical properties and very high formability. So basically we have a lot of possible applications on the body in white.
Oh, and we have a question from someone who actually congratulates you on a great presentation, but I think they work as a CSR manager, and do you have any advice for someone in that position who's trying to persuade the decision makers, the people with the financial muscle to make such investments?
Gosh, I mean, what's worked at ArcelorMittal is a word I use a lot is narrative. What does the future world look like? How does your business fit into that future world? What are the opportunities? And what do we need to do now to grasp that opportunity, as well as mitigating the risks? Also capture and reflect on what investors and customers are asking. I mean, a lot of the outcome of both the carbon report and responsible steel weren't just conclusions the CR function reached at ArcelorMittal. It was in response to listening and understanding where the customer investors' ask was. And I just don't mean the question one investor asked us today, but what does that mean? What's that a signal of? If that investor is asking that question today, what question will they be asking us in 5 years' time? And what other stakeholders will be asking that question? So use today's dynamics as a sort of as a prod for what the future looks like. Because one of the things about the changes we need to make to our business, be it the products or the steel making process, is you can't make them overnight. So when all our customers are asking us for low carbon steel, when all our investors are asking us about low carbon steel making, it's too late. So that's what I say. What are the soft signals we're getting to now? What will they look like in 5 years' time? From that, build a narrative, tell a story like the carbon report, and then create 3 or 4 big asks of the business. I mean, you saw in my presentation at the end, I ended with 17 sustainable development goals, which is the world leaders agenda. I then had sort of 10 defining principles, which we call our SD outcomes. But then I spent most of my time talking about the area where we're making most change, which is taking carbon out of steel making, more levels of reassurance, and then that was supported by how we're making our customers' life more sustainable through the product innovation agenda we're driving. And all of those are very commercial. They're talking to stakeholders and they're talking about the future. That's quite a long answer, but that's the sort of the overall approach I've taken in my role as contribution towards the ArcelorMittal and in previous roles, and it tends to work.
Oh no, that's great, Alan. Thanks very much. Okay, I think we'll draw it to a close there, but thank you for all of your questions. Any that we didn't have a chance to answer here will be sent on to Alan and Jérôme to follow up directly. So again, we'd like to say thank you to Alan and Jérôme for a very informative webinar. As always, the webinar will be uploaded into the AMS website and accessible in future for your colleagues who've been unable to join us for the live presentation. You can access this and all of the previous webinars via the Voice of the Industry link at our website. We'd like to get your feedback on this webinar, so there's a short survey coming up. Please take the time to complete it. We very much appreciate your input. So thanks again for taking part with us today. I'll hope you'll join us again next time. Thanks and goodbye.
Thank you.
Brilliant.